Good evening. Massively happy New Year to everybody. Hope you all had a good one.
Yeah.
Marvellous. Okay, kicking off 2018, we have Tony Wright. I first saw Ian Crane's AV8. Tonight, author Tony presents Children of the Forest. He takes an intimate and historical look at humans and our relationships with certain food and their effects upon us in our evolution. Tony also brings his book, Return to the Brain of Eden, which is 20 years in the making. Please welcome Tony Wright.
Just get my toys sorted out. Okay, thanks for coming. Thanks, Rob, for the invite. So, what am I going to talk about this evening? You can see from the title, it's kind of quite a big question, and I hope I'm going to provide you with some interesting information. I'm not going to tell you answers, but I'm going to try and, I guess, suggest what I've discovered over the last 20-25 years to do. Really, it's about, I suppose, why humanity has gone insane. And I've really been looking at fundamental causes. What is it right down in the basement that drives what appears to be our increasing self-destructive behavior, and what has resulted really in the social systems we have, the political institutions we have, all the kind of things that we get pretty cheesed off about. I'm really looking as to how that has emerged, how we've ended up here. And some of the things I'm going to suggest might initially not really seem that relevant. They might not make much sense, because I'm going to cover quite a sort of broad area and then hopefully bring it to some kind of conclusion towards the end. So it might be a case of just holding on to the pieces, and then hopefully towards the end, some of them at least might fit together with any luck. So, as I say, pretty grand questions. This is really what I've been more or less obsessed with for the last 20 odd years. Who are we? What are we? Very old questions, very ancient questions. And I do draw on quite a lot of what might be called ancient mythology, ancient traditions. But I've also tried to marry it up with modern Western academic tradition. I think there's a lot of really good data there. I'm not always so inspired by the conclusions. But it is a mixture of different traditions, and I actually think they tell the same story once you step back and ask perhaps slightly different questions. And in essence, I'm really trying to develop what I would call a diagnosis as the first step towards trying to treat what I'm kind of proposing is species-wide insanity. It's not just at the very top of the hierarchy of madness, but really, if we're honest, I think we can all see unusual aspects of our own psychology, our own behavior. We see it more easily in other people, but of course everybody thinks exactly the same about us, and it's always a little bit uncomfortable to look in the mirror. So I'm going to start with a little bit of, I guess, a conclusion, and suggest that you test this against the information I'm going to work through, present over the next hour or two, and see how it fits. But I think it's sometimes helpful to get an idea of ultimately what I'm trying to say, and then you can see how the pieces fit together. And I'm going to draw a little bit on something you're probably quite familiar with, classic left-right brain material, been around for quite a long time now, certainly 40, 50 years, even longer. And I think there's some absolutely fascinating material in there. It's been somewhat eroded over the last 10 to 20 years. There's been a suggestion, or quite a lot written in sort of mainstream publications, that it's not that simple, it doesn't work like that, based on modern imaging data. But actually the modern imaging data, the way it's been interpreted, I think, is highly suspect. I think there is a real story here. It's as simple as it was in the early experiments in the 50s, 60s and 70s. A I've even got a bit of footage if we've got time to show you. See how we get on. Can you read that? Is that legible at the back?
Yeah.
So I'll just give you a little minute to read that, and then we'll start getting into the various areas that I think relate to this, some of which, as I say, might seem a bit unusual, and then hopefully start pulling it together. I'm essentially saying the dominant part of our character, the dominant part of our psychology, the kind of I we normally relate to, our normal sense of self, the neurology that underpins that has some quite serious problems. But because that's what we're bound to, that's kind of the filter we always look through, we tend not to see the problems, we tend to look outward and see the symptoms. Also going to try and weave in a little bit of classic Darwinian evolution, really looking at human origins. Again, I think there's a lot of interesting data, and I actually think it fits a lot of the ancient mythology quite well. Again, once you step back and look at the bigger picture. And just dwelling on this slide, the kind of current thinking, kind of coming out of the Western academic tradition, is that our distant ancestors spent a huge amount of time in the forest, tens of millions of years, didn't really get up to much, nothing much interesting happened there. And then as we emerged from the forest, somehow by means not fully understood as yet, we developed a very large brain and intelligence, and then went on to create civilization. So sort of moving from this through all these wonderful inventions, and we end up with allegedly the sort of pinnacle of civilization. Kind of an obsession with rockets and big shiny buildings, and you see the scale change. This is kind of the human scale now. We're in awe of what we've created. That's the story we're told anyway. And our culture, especially the last 50, 60, 70 years, has gone into overdrive. More and more technology, and we're almost digitizing ourselves. And the story again, at least what the ad men tell us, it's fantastic, it's more, it's better, it's faster, it's quicker. Of course, within all of this story, there's massive kind of, I suppose, I wouldn't say, it's more like denial really, things that don't fit. And most of the culture that we're encouraged to aspire to is still built on slavery, has been for a long time. And the supply chains, you don't have to go very far down the supply chains for the stuff that we all buy and use every day to find modern equivalent. Incredible poverty, incredibly difficult lives. And our culture relies on this to survive. So I'm really just pointing out the obvious stuff you're already familiar with, but I think it's worth a quick reminder. The juxtaposition between this idea that we're advanced and everything's okay, and these difficult to explain anomalies. Obviously, warfare has been a significant part of human history for at least the last few thousand years. And in modern times, I think we've killed at least 100 million of our own kind in the last 100 years or so. And some of our best technology tends to come out of the military research. We've ended up investing huge amounts of resource to invent ever more efficient ways to kill each other. And we kind of know this, but it's so embedded in our culture, tends to just slip under the radar a bit. In fact, most Western economies are propped up by defense contracts, defense industry. So the idea that we're advanced and functional, to me, is, well, these clues are just so massive, but we're so used to them. And then even within the midst of, again, allegedly the sort of pinnacle of Western culture, these giant cities, you don't have to look very far to see how much of a failure they are. And again, looking at the human element, we get carried away, or our dominant psychology gets carried away with the shiny, big, square things. I mean, there was probably forest there 200-300 years ago, and look what we've done to the place. I think that's supposed to be a major American city. And when you actually speak to people, of course, the story is very different. Things aren't quite so rosy. The actual harsh reality is, after years of this culture that's promised so much, the reality is, if anything, it's getting worse. It's more stressful, confusion, absolute epidemic of degenerative diseases. Really isn't working as well as it's supposed to. It's nothing like what it says on the box. Now, before the kind of advent of Western science, our natural history, our ideas of who and what we are, came down to us in various traditions. Ancient oral traditions, some of those have been distorted and lost, particularly in this part of the world. Some of them still exist in partially intact forms. And then some of that's been codified and it's been brought into the idea of modern religions, but they still tell similar stories. The ancient mythology of mankind has parallels in some of these great religions. And the story's interesting. The common theme is that at one time we were very different to what we are now. And I don't mean physically necessarily, I mean the way we perceive ourselves, the way we would describe ourselves. And they generally allude to a time where, in fact, things weren't just a little bit better, they were phenomenally better. Talk about a time where we really experienced a sense of connection with nature and with each other. And we were in a state of almost divine wonder. That was our kind of normal state. Sounds a little bit fluffy, sounds a bit of a hippie sort of ideology, but when we start looking at the biochemistry in a bit, it does actually start to add up. And these same traditions, some of them are quite detailed, some are a bit more vague. They talk about this time changing because of some kind of disaster, some kind of, often an ecological disaster, but some kind of major upset. And things began to change, our perception began to change. And we began to see the emergence of a sense of self that we'd start to recognize today. So there was this ancient sense of self, this, again, I'm using the word, I guess, divine, but not in any particular religious sense. Just a very heightened state, a very kind of wondrous state in many ways, often described as a very innocent time. That sense of self began to retract, and this new sense of self began to emerge. And they seemed to coexist for a long time, again, according to these traditions. And then eventually, this new self began to completely dominate, and we lost connection with this more ancient self, or it became very hard to experience. And interestingly, some of these traditions do talk about forest origins. One of the stories we're most familiar with in this culture, its exact origins are still the subject of a lot of debate, but they've been codified in the kind of Judeo-Christian tradition. Living naked in the forest, so presumably it was warm, and our very genesis had something to do with that time. And they even talk about relationships with trees and eating fruit. And I'll get onto that in a little bit. Fruit is going to feature in this. Again, this is just a visual representation. The idea that we lived in a state of mind, a perpetual state of mind, radically different from what we experience now, but hinted at in these traditions. In fact, these traditions often come with what are called practices, techniques, really designed to take us back to our ancestral state, or glimpses of our ancestral state. Treatments, really, I think, is the appropriate term. Of course, the question is, what were they treating? What was the nature of this condition? And I think it's interesting if you start dissecting the practices, the techniques, or I'm going to call them treatments, from all these great traditions, you can frame them in a kind of neurological context. They were trying to treat a very specific condition. In fact, it was the core of many of these traditions. There seemed to be an awareness that something serious was going wrong, and there was a lot of very clever attempts to try and ameliorate the conditions, at least slow it down, or at least allow us access to these state of minds that were more functional, less aggressive, and so on. And again, there's certainly a lot written, increasingly in fact, written around these states, linking them to changes in neurochemistry. You can change the structure of your neural system, change the chemistry of your neural system, and depending on how you do that, some of these states start to re-emerge. They're not necessarily sustainable, but we clearly have wiring for these very unusual states. And again, this theme is common throughout these traditions, regardless of the dogma that's kind of been woven into them. They all talk about these archaic states in a very similar way. And when people experience these states, sometimes spontaneously, but often through various kinds of practice, the deeper the state gets, the more commonality it has. Essentially the same state. And it's not a contracted state. When I say that, it's not kind of condensation into a more limited state. It's a much more expansive state. But it becomes increasingly difficult to put into words. But again, terms like divine, rapture, very, very powerful terms. Whereas a day-to-day state really is based on concepts, beliefs and concepts. We tend to mistake them for reality. So if you think about it, if you think about how we define ourselves, if you take away the labels, if you take away the term human being or spirit of light or whatever you want to call yourself, your name, your job title, your nationality, strip all the labels away, nothing that you can put into words, in what's left. What is it you feel? How would you describe that? So we're so used to using these concepts and labels. And really, in our current state, that's pretty much what most of us are left with. That's our main way of operating now. We trade concepts and ideas. It's not reality, but we tend to mistake it for reality. So again, touching on the split brain research, what emerged from research in the, I guess, 50s, but particularly 60s, 70s, is that we have two selves residing in our skull, two quite distinct beings, but mostly we refer to ourselves in the singular, me or I. We tend to feel like we're a single person. Not everybody, not all of the time. But the evidence is quite compelling. Hidden behind our day-to-day self, there's another self. Tends to be quite hard to access, tends not to have much of a voice. We tend to be dominated, again, as I say, by speech and these concepts. But there's another self living in there. and it seems to have phenomenal capacity, way off the scale compared to normal. And it seems to be latent in everybody. There are phenomenal capacities locked away in everybody. Why on earth is it so difficult to get at? Why do we have such amazing abilities, the classic savant-like abilities, prodigious memory, phenomenal cognitive function, and the capacity to feel amazing? And yet, for the most part, most of us don't feel like that or don't have access to those abilities most of the time. And the neurological data and the psychological data associated with that research is fascinating. Definitely an area to have a look at if you've not already, and if you've looked at it before, take a look at it again. The data is absolutely fascinating. The conclusions, I think, are a little bit suspect, and we'll get on to why that is the case in a little bit. This is another area that I've done quite a lot of research in. Sleep generally still considered a bit of a mystery. What's its purpose? How does it work? And humans in particular have a lot of, I guess, unusual traits around sleep. I've listed a few there. It's things like lucid dreaming, which you may be familiar with. Sleepwalking, how on earth, when we're asleep, we can take our body off, or something takes our body off, and we can go off and do quite complex things. There's quite a lot of evidence now, people getting up in the night, wandering around the house, maybe going to the fridge, making some food, going back to bed, no recollection. And even more adventurous, people getting in the car, driving, even robbing banks. Whether that's just a clever defense or not, I don't know. But certainly there's something that when we're in what we consider a sleep state, something else can take our body and go off and do all sorts of strange things with it. It's also tied in with some of these ancient traditions, not so much sleeping, but actually staying awake, not sleeping. There's quite a few traditions propose that if you stay awake long enough, and I'm not talking about missing a night, but maybe 3, 4, 5 nights of sleep, staying awake 3, 4, 5 days, even longer, it can take you to a state that's actually more functional. Sounds crazy, sounds like it wouldn't make any sense, because most of us know that you miss a night's sleep, you feel dreadful, irritable, desperately want to get some sleep. And that's what most of us do. We kind of sleep, we recharge, we never really question that. But a lot of people over history have used staying awake to get to so-called altered states. And I'll try and explain how I think that works in a little bit. Handedness, again, I think is another major clue. We're all familiar with it. Most of us have got one hand we pretty much obliged to use. Lots of species have what they call paw preference. They'll prefer to use one side or the other, but they can use both sides equally if they need to. Humans, quite unusual in that, again, most of us have one hand that we have to use for fine skills, fine motor skills. We use it more of the time. The other hand, again, I'm quite strongly right-handed, so my left hand feels quite clumsy and awkward, particularly for fine tasks. I can't get it to do things as well as I can get my right hand to do. Why on earth would we have a hand that's not as useful? What is the adaptive purpose of that? Well, I'm going to suggest it's not really an adaptive, it's not the product of adaptation. It's a symptom of how lopsided our neural system is. There's something very lopsided, but we're so used to it, we kind of don't question it. Touched on this already. Lots of labels, higher function, altered states. And again, I've already touched on savant syndrome and kind of prodigious genius type function. Clearly humans have the wiring for that. It does emerge under certain circumstances. Why is it so rare? How can we have the wiring for it, and yet for the most part it's difficult to access? Some people go through their whole lives and never really get a glimpse of this, and yet it lives in us somewhere. You may be aware that speech is primarily lateralized between the hemispheres of the brain. It's primarily left hemisphere, the dominant hemisphere. And it's often regarded, speech is often regarded as one of our major adaptive triumphs. We've learned to master speech and we can communicate in the way I'm doing now, and it sets us apart from virtually all other species. However, I find it quite odd that we have capacity to use something similar to speech, which is a lot more efficient at communication. Brings with it an awful lot more information, a lot more understanding, and that's singing. And our left hemisphere generally, particularly once we're past the age of puberty, finds singing very difficult, and it often doesn't sound very good. Yet most of us, again, behind our speech capacity, have a singing voice. It often comes out when we've had a drink or two, when we're very relaxed. Even people with speech impediment, they have a drink and they can start singing. It often sounds amazing. And I think it's interesting to think about if we actually sung to each other all the time, the way we communicate, operatic style. It'd be kind of difficult to get really pissed off with anybody if that was going on. It would just be too hilarious. But for the most part, and I include myself in this, we're too scared to do that. We could do it. Why don't we? And we don't really want to talk about things that scare us. But all the neurology suggests singing is primarily right hemisphere, or at least the singing we like to hear, the in tune, the perfect pitch, this kind of stuff. We can kind of do an approximation with the left hemisphere, but often it sounds pretty bad. And again, I'm suggesting that one of our hemispheres has lost a lot of ability. And I think that's our speech-dominant left hemisphere. But currently it's in charge, and it really likes to think it's super clever. Therefore, speech is, of course, highly advanced. Singing is a bit mysterious. How did it evolve? Where did it come from? The fact it's more complex than speech, and yet we don't use it, is one of those anomalies that we don't really want to talk about. So again, another apparently distinct area, might seem quite unrelated to the idea of our general mental health. But again, I hope all these things will kind of start joining together. Human reproduction, human fertility, some quite unusual anomalies in the human condition. Some things that we've become quite attached to, even revere. But when you step back and you look at the mechanisms and the biochemistry, some interesting things start to stand out, particularly in relation to female reproduction, female fertility, and the end of fertility, menopause. Some quite unique features, highly unique to humans. A lot of research, a lot of attempts to understand what's going on. What most people have forgotten, even though it's in the literature, that humans in our distant past, remember when we lived in the forest, not only did we live in the forest, but we ate this stuff. And this is not what you think it is. This is the female reproductive organ of the flowering plants, the angiosperms, the flowering plants. All right, we call it fruit today, but as you know, fruit, unless it's been severely hybridized, has seeds in it. It's the plant's rough equivalent of ovaries, uterus, and so on. And we actually formed a relationship. We're eating this stuff 24/7 for millions of years, flooding our system with the reproductive biochemistry of the angiosperms. And in essence, humans co-evolved into a kind of symbiotic relationship with this stuff for tens of millions of years. So really there were two reproductive systems co-evolving for a very long time. And when you think now about admittedly the sort of corporate and pharmaceutical push for HRT and all these kind of synthetic solutions, the reason we're in these kind of strange situations is because this has gone missing. This was part of evolution for a very long time, co-evolved, eating this stuff. Now we don't, not in the quantities we used to, and all the chemistry that used to be part of our symbiotic regime has gone. It starts to make some sense of some of the anomalies in human reproduction. And it's hinted at in some of these ancient traditions as well. But in essence, basically you take a basic mammalian system. Mammals are, if you like, parasitic on plants. Plants have been around for a long time. They do all the heavy lifting. They take all the complex stuff from the soil, the atmosphere, the phenomenal chemical factories, and they transform it into energy, into structure, build these amazing structures. Then mammals come along and eat it. They're basically, plants do all the hard work. Mammals, say in many ways, are parasitic on plants. And mammals generally don't have such a big genome. They're not as complex. They don't have such large DNA. They don't produce anything like the complexity of chemistry that plants do. So when our ancestors formed what's called a symbiotic relationship with the forest, say specializing in eating the reproductive organs of plants, we're taking vast amounts of complex chemistry from the plants, and it was in a form that wanted to be eaten, which is very rare. Plants generally defend themselves. They don't like being eaten, so they build in all sorts of chemical barriers, and animals have to overcome it. But the reproductive organs, the fruit, are the ultimate free lunch. The plant actually wants it to be eaten, and it's chemically designed to be eaten for the most part. It's not toxic, very few exceptions, and it brings with it a load of reproductive biochemistry. So you can start to make sense of the human reproductive system when you start looking at it symbiotically. And once you lose this stuff, again, it's like losing the majority of the chemistry we evolved with. Our mammalian system can't compensate. So it ends up starting to revert to a more typical early mammal. And we get the re-emergence of menstruation, ovulation, and menopause. Another area, again, a lot written about this. And it's really, I think, a measure of our mental health. That humans, particularly in our culture, but increasingly and generally, we're very frightened, almost paranoid. When you think of all the rituals and rules we follow, and we know not to cross the lines, we know what to say and not what to say. We don't like people to see us for who we really are. We're actually very frightened. So frightened we don't want to talk about it. So frightened we don't want to admit to it. And everybody's playing the same game. Very, very few exceptions to that. And fear is a typical symptom of mental ill health. And again, going back to those ancient traditions, in this archaic state there was no fear. Not this irrational fear anyway. And there are techniques around today, people still experience this, where they go from this normal kind of sense of mild anxiety that we all keep hidden away. Some of these techniques, when they work, when you engage with them, you move into a state, lots of unusual things happen, but one of the things people report frequently is, oh my God, the fear's gone. That nagging fear that's been there all my life disappeared. So again, we have the wiring for a place where we don't feel fear. And it's not a naive place. It's not a place where you wouldn't get out the way if you needed to. It's more like the kind of Zen martial arts type objective where you train the mind, and eventually you have phenomenal awareness. And you can react and you can do whatever you need to do, but it's not being driven by fear. It's being driven by very, very high awareness. Very, very different state of mind. Another area of clues. Again, all these areas individually, they're a whole subject unto themselves, so I'm just skimming across them and saying really they all join together. Ties in with fear. Increasingly we've become frightened of profound pleasure, culturally and individually. It's been increasingly regulated as our history's evolved. Anything to do with profound pleasure. It's okay to feel excitement and anticipation about buying a new car, a new stereo, or having a giggle at X Factor or whatever. But really deep pleasure, the kind of pleasure where you have to get out of your normal state of mind, generally restricted. And that includes anything that can induce those kind of deep states of pleasure. So for example, there's certainly, in terms of the way we become more and more frightened, there's certainly cultures that probably would have banned sex altogether if it wasn't for the need to procreate, because sex in these ancient traditions was one gateway into these altered states, and it involved a deep and profound pleasure. And that's not something our dominant left hemisphere can feel. If we could feel like that, we'd feel like that all the time. We have to do something to get out of our left hemisphere to feel these kind of states. So again, I think there are cultural clues, historic clues. You can almost see us moving in a more controlled, a more paranoid state, and shutting the door on the very things we need to feel because they're too frightening, because it requires us to let go of a normal sense of self. Again, these ancient traditions tend to allude to humans being exceptionally healthy and living a very long time. Now, I can't say for sure whether they're accurate or not, but there is a common theme. And it's interesting when you look at how humans develop and how our immune system develops and how sensitive it is to some of our own hormones, particularly the thymus gland. It tends to expand when we're young, and as we start going into puberty, it slows down and then starts shrinking. And that's controlled by hormones that I'm going to talk quite a bit about, our own sex hormones, things like testosterone and estrogen. They tend, as we move into puberty, those levels increase, they tend to start shutting down our immune system. And that's kind of how it's considered to be. It's kind of, that's the normal process. Back to what I've already touched on in our distant ancestral past, when we were living in the forest, we're eating a lot of these reproductive organs. They're loaded with chemicals that inhibit our own sex hormones, our own steroids, the very things that start dampening down our immune system. So going back to this symbiotic time, we tend to think of ourselves as standalone mammals, but you have to stop thinking like that and start thinking about symbiosis, organisms joining and almost becoming a singular new organism. In that epoch, our own hormone regime was highly modified, and it basically prevented these kind of things happening. It stopped us going into such early puberty, and it stopped the levels of hormones doing the same things they do now. So basically things like our thymus gland would have kept growing at least until we were adults, and it would have functioned much more powerfully right throughout our lives. So it sort of lends a little bit of weight to the idea that some of these ancient myths of longevity and great health are actually based in some historic memory rather than just some kind of nostalgic primitive thinking, as these traditions are often dismissed as. I'm not going to spend too much time on this. Again, each one of these slides is a whole story here, but I'm sure you've come across the increasing interest in the pineal gland and the role it plays in altered states. A lot of interest in whether it produces DMT or not. I think the jury's still out on that. There's increasingly evidence emerging that maybe it has that capacity. But our pineal gland also produces other chemicals. It produces melatonin and pinealine. Very powerful chemicals, kind of hormonally active chemicals. And they act in a similar way to the chemicals in fruit. They tend to dampen down our own hormones. Now on its own, that piece of information, well, what does it mean? But bear that in mind. Our pineal gland has the capacity to produce chemicals that dampen down our own hormones if it's stimulated. So again, talking a little bit about our own hormones again, I'm sure you're all familiar with testosterone. Primarily a male hormone, but not exclusively. Females produce testosterone as well, just lesser amounts. And it's been increasingly correlated with certain kinds of behavior. But again, we've tended to look at ourselves in isolation, isolated individual mammals, and looking at all the levels of our hormones and how they work. If you look at this in context, if you look at how we evolved in the forest, the activity of these hormones would have been greatly reduced. When you take the brakes off, when you leave the forest and leave the influence of the reproductive biochemistry of fruits, then relatively speaking, our own hormones become more active, particularly things like testosterone. Being a male hormone, primarily a male hormone, it has a bigger impact on men. So in essence, I think historically, as this relationship with the forest has faltered, broken down, and we've been exposed to our own ancient mammalian hormones, it's changed the way our systems work, particularly how our brain develops, particularly how the male brain develops. And it's almost, testosterone's almost trying to build an ancient mammalian brain. Ancient mammalian brains, very effective, they survive, been around for a long time, but they generally not too bright, they can be very aggressive, very hierarchical, not much empathy, not much compassion. And as we become exposed increasingly to our own hormones, it's sculpted our brain, it's slowly been changing our brain into something much more primitive. Particularly one side of our brain's been hit harder than the other. And lo and behold, it turns out to be the dominant what is now the dominant hemisphere, our left hemisphere. So it's been sculpted increasingly as if it was a much more ancient brain, a much less functional brain. And I'm going to go as far as suggesting that really the emergence of hierarchical systems and patriarchal systems, it seemed to have emerged somewhere in the last 10, 20,000 years. It's difficult to be sure. It's really a symptom of a neurological decline. As our brain has become less functional, we become more frightened. We've started creating these structures to support our beliefs of fear and or to manage our feelings of fear and our need for control, to control the fear. So the emergence of patriarchal culture, I think, has a lot to do with being exposed to too much of our own hormones after a long time of not being exposed to them. So quite a few pieces again. I know it probably sounds a bit disjointed at the moment. Hopefully they'll start coming together. So really, having sort of trawled through the literature in a lot of these areas, I really wanted to get to understand how things originally worked, how things evolved, and how they may have been different to what they are now. And using sort of being a male, using some very basic engineering analogies, when you're designing something, building something, constructing it, fueling it, particularly if it's very complex, you tend to have very tight specifications. If it's a very complex system, if you're building a 747 or whatever it is, design is incredibly important. You haven't got a lot of latitude with design. You get the design wrong, it's not going to work, it's going to be dangerous. Building materials, again, the specification can be very tight, but usually you have a little bit more latitude. You can swap the building materials around a bit. It might not work quite as well, but you're probably going to be able to build it and it might still work. Same with fuel. There'll be an ideal fuel, but there might be some scope to substitute fuels or use lower octane fuels, less performance and so on. Really very basic engineering kind of parameters. And when you apply them to the most complex thing we know, which is generally regarded as the human brain's generally regarded as the most complex thing we know, and you look at what's happened in our history, it's not surprising we've got serious problems. We tend today to treat our brain as if it fell out of the sky and we just build it from any old rubbish and expect it to work. But the history, and it's strong, there's a lot of data in Western science, as I say, I think the data is very good, suggests that we spent the longest time in the most complex molecular ecology we know. So you think complex systems, where did it come from, how did it evolve? Well, there's lots of theories kicking around, but it's known that we spent, or it's generally accepted, we spent a huge amount of time in the forest, the tropical forest. And what we know about the tropical forest is it is biochemically the richest place by light years. That's why the pharmaceutical companies are always witching around in the forest, trying to come up with new drugs to synthesize and to patent and sell us. They usually don't work very well because they're not exactly the same. But we lived in this place for millions of years, and that's kind of what we got used to. And not only that, as I've already touched on, it's not just that we were living in the forest, we were eating fruit. We're seed disseminators. Our biology, our basic structure suggests we have an arboreal origin, and our physiology, despite what you might read in the popular press, it's acknowledged to be essentially frugivorous. So not only were we living in the most biochemically rich environment, we were ingesting the reproductive organs of these same species, very chemically rich species. We formed a symbiotic relationship. We're ingesting this stuff all the time. And the reason that's important, talking about design, normally you'd think of a blueprint and you read the design and build something. Well, design in the human sense, I'm not necessarily talking about the kind of religious ideas of design or intelligent design. I'm talking about how the DNA is turned into structure. Kind of basic theory is DNA is the blueprint, and that's responsible in some way for building us. But of course the DNA doesn't do anything unless it's read. And how do you read the DNA? Well, some of the major players in reading the DNA are hormones, things like testosterone, estrogen. I've already touched on them. So they're part of the design. Well, when you start adding the reproductive organs of the angiosperms, the flowering plants, into the equation, they change the design because they're changing the hormones. I've already said they'll affect the way our own hormones work. So they have a big impact on the design. They tend to dampen down the effect of things like estrogen and testosterone, and you end up with a very, very different outcome. So the basic idea, say, particularly from Western science, is DNA is incredibly important in how we evolved and how we work today. And the code's stored in these chemical bonds, and to get from the code into structure and then eventually to function, this process is where the hormones play their role. So hormones really dictate how this is translated into proteins and structure generally. And normally how this works, so you have your DNA code, and it's read by the hormones. The hormones build structure, builds our body, including our brain, and gets into a bit of a tight loop because our brain runs what we call the endocrine system, the hormone system. Of course, it's the hormone system that reads the DNA, so it's kind of quite incestuous. It's quite a closed loop. DNA builds system, builds a brain runs a hormone system, hormones read the DNA, round and round it goes. In the maternal line, of course, that affects the next generation from conception, in fact even the development of sex cells, the eggs and so on, that's also affected. But in the female line, this affects the development of the next generation and how the new brain develops. But normally this is a very stable loop. You do get changes, you get windows of development. So when we're in a juvenile phase, when we're babies, post-fetal development, and then juveniles, almost different species, very different behavior, very different brain. Then the hormones kick in and changes our whole physiology. It also changes our brain. we become sexually mature. This is a kind of standard model. And quite interesting, actually, we'll touch on this in a bit. Our brain changes a lot during these hormonal changes through puberty and as we get older. In fact, each side of the brain is genetically distinct. And remember, it's hormones that read the DNA, the genetic code. So if you change the hormones, you get a change in how the brain develops, each side of the brain develops. And as we get into puberty, one side of our brain develops differently to the other, and that's where we start getting this cerebral asymmetry and eventually cerebral dominance. Children have much more symmetrical brains. Women have more symmetrical brains than men, so there's like a scale there from children very symmetrical, women quite symmetrical, males much more asymmetrical. It's all down to hormones. Basic biology, it's pretty well documented. I'm not really saying anything new. So sex steroids, they regulate all of these things. Generally neural development, the degree of cerebral asymmetry, so how much our brain is symmetrical or not. Masculinization process, including the brain, how masculinized the brain gets. And that's not just males, that's females as well, because remember, females produce testosterone. These steroids also regulate specialization, differentiation, so our brains change from a much more uniform state when we're babies, when we're young, becomes much more structured. Sexual dimorphism, the difference between the sexes, again, that's modulated by hormones. Age of sexual maturity, well, you've probably read a lot about that. It's changing. The age of puberty is dropping, particularly in women. It's dropped maybe 10 to 15% in the last 100, 150 years. We should really be alarmed about that because it's the window for our brain development and our brain growth is prior to puberty. Once puberty hits, it all starts slowing down and it's a maturation process. The growing window is when we're juvenile. So having this reduced age of sexual maturity, we're losing this juvenile window when we grow our brain. Same hormones also regulate other developmental windows, all sorts of windows that lead to when we're sexually mature, when the fertility ends. They play a major role in everything. Basically, they read the DNA code, they tell the DNA code what to do, and they dictate the windows of development, everything from when we're conceived right the way through until we're adults and beyond. So very, very powerful. The more steroid activity you have, the greater